Dear colleagues, good morning. Today it's August 17, 2021, 12 noon. And we're beginning the panel session for the defense of the thesis by Elmahalawy, Yasser, Reda, Ahmed, Abdelhamid. This is submitted for the academic degree of the candidate of sciences in physics and mathematics. The specialization is 133, theoretical physics, previously titled 010402, theoretical physics. And the topic of the thesis is quantum aspects of the problem of time in gravity and cosmology. And I'll talk about the academic code specialization later. Under the order issued by the Academic Secretary of St. Petersburg State University, as of May 13th, 2021, number 4823/1, I, Sergei Afonin, Doctor of Sciences in Physics and Mathematics, Professor of the Department of High Energy and Elementary Particle Physics of St. Petersburg State University, was appointed the chairperson of this dissertation board. The order also approved the candidacies of the members of our board, and let me introduce them. Sergei Paston, Doctor of Sciences in Physics and Mathematics, Associate Professor of the Department of High Energy and Elementary Particle Physics of St. Petersburg State University. The following members of the board are working remotely. Victor Berezin, Doctor of Sciences in Physics and Mathematics, Senior Researcher of the Theoretical Physics Department of the Institute of Nuclear Research of the Russian Academy of Sciences. Do you hear us and see us? Yes, I do. Okay, the answer is yes. Then, Alexei Jung, Doctor of Sciences in Physics and Mathematics, leading researcher of the Theoretical Physics Department of the Konstantinov St. Petersburg Nuclear Physics Institute of NRC Kurchatov Institute. Alexei, do you see us and hear us? Yes, I do. Okay, thank you. Then Alexander Kamenchik, Doctor of Sciences in Physics and Mathematics, Professor of the University of Bologna, Italy. Alexander, do you hear us and see us? Yes, I do. Okay. And Alexei Golovnyov, Doctor of Sciences in Physics and Mathematics, the British University in Egypt. Alexei, do you hear us and see us? Yes? Yes, the answer is yes. Okay, thank you. And we also have our candidate for the degree, Yasser Elmahalawy. And in a few minutes, the thesis supervisor will also come. He's coming already. That's Alexander Andrianov, Doctor of Sciences in Physics and Mathematics, Professor of the Department of High Energy and Elementary Particle Physics of St. Petersburg State University. And I would like to inform you that the panel session of the dissertation board is being recorded and broadcast on the St. Petersburg State University website. And here is Alexander, the thesis supervisor. And also, our panel session is interpreted into English and into Russian. Currently, we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions to Mr. Elmahalawy online, the questions regarding the thesis and the current academic discussion. These questions will be forwarded to me by our technical service, and I will read them out during the discussion. Questions must be related to the speech of our candidate for the degree and to the content of the thesis. And don't forget to give your name and position if you submit a question. And the questions that have nothing to do with this, with the scientific discussion or the dissertation text will not be voiced. Now a few words about the specialization code. Elmahalawy, Yasser, Reda, Ahmed, Abdelhamid has submitted an application for the defense of his thesis with the specialization 010402, theoretical physics. However, in order to execute the order of the Ministry of Education, Ministry of Science and Higher Education as of February 24, 2021, number 118, on the approval of academic specialization nomenclature for scientific degrees, and the amendment of the regulation on academic boards approved by the Ministry of Education and Science as of November 10th, 2017, number 1093, a new nomenclature of scientific specialization was introduced, and given the fact that our board was previously approved by the academic secretary for the same specialization, I've already given you the number of this order, so it was approved for the same specialization, theoretical physics. We just had to change the code number because we already have the order as of September the 1st. And this board includes the experts in this particular topic. And the title was just the same, theoretical physics, and a new nomenclature, the code, was changed, therefore taking into account the petition of our applicant as of August 5th, 2021, number 3305101, about the change of the specialization code from 010402 into 133 theoretical physics in the new nomenclature. And as his thesis completely corresponds to the scientific specialization of the new nomenclature, we changed the order on the approval of the thesis, and our academic board was approved for the defense of Yasser Elmahalawy's thesis in specialization 133 theoretical physics, and that's the order of St. Petersburg State University as of August 9th, 2021, number 7844/1. So that's it. Dear colleagues, are there any questions on the issue or any comments about it? None. Okay. So, the thesis by Elmahalawy, Yasser, Reda, Ahmed, Abdelhamid is submitted for the academic degree of the candidate of sciences in physics and mathematics. The specialization is 133 theoretical physics, and the topic of the thesis is quantum aspects of the problem of time in gravity and cosmology. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local normative acts, the session of the Dissertation Board is valid, providing 2/3 of the appointed board members are present, and the total number is not to be fewer than 4 people. The Dissertation Board consists of 6 people, and everyone is with us today, including full members of the board who are working remotely. We have a multimedia connection with all the members of the board as well as with our candidates for the degree. Therefore, we have the quorum. So our session should not last more than 2 hours, and the agenda is as follows. First comes the chairman's short presentation about the documents submitted by the candidates for the degree and their conformity with the requirements. The chairman's replies to questions, if any. 5 minutes for that. Then a short report by our candidate for the degree, providing an overview and findings of the research, 20 minutes for that. Then questions to the candidates regarding the presentation, and more than 2 minutes per question. Then the candidates' replies to the questions, 10 minutes for all questions. Then the reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions on the thesis. 10 minutes per speaker. Then the chairman's report on the thesis, also 10 minutes for that. Then the candidates' comments about the reports on the thesis and replies to the questions, 20 minutes for all. Then open discussion. Anyone present at the defense may state their position or ask questions on the thesis, or maybe provide certain offers on the topic of the study. 2 minutes per person. And at that, I kindly ask you to fill in the registration form and introduce yourself before I give you the floor, if you want to speak out. Then the chairman will ask the questions submitted during the broadcast via our website. Then the candidate's replies to the questions, 2 minutes per question. Then the presentation of the candidate's thesis supervisor, 3 minutes for that. Then a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of the results of the defense is not broadcast. Then comes open balloting, vote counting and recording of the results in the protocol. And then we're going to make a decision on whether to confer the academic degree or not. And finally, we're going to listen to the candidate's closing speech, no more than 2 minutes for that. So, distinguished colleagues, any questions or objections on our agenda? None. Okay. If there are no questions, let us proceed. But before we do that, I kindly ask you to switch on the sound on your mobile phones. Thank you. So I need to switch it off myself. Well, the chairman's presentation. The thesis by Yasser Elmahalawy for the academic degree of the candidate of sciences in physics and mathematics, the specialization 133 theoretical physics, is titled Quantum Aspects of the Problem of Time in Gravity and Cosmology. The thesis was approved for the defense by the order of Academic Secretary of St. Petersburg State University, issued April 1st, 2021, number 2651/1. Mr. Elmahalawy has prepared his dissertation at St. Petersburg State University, and Professor Alexander Andrianov, Doctor of Sciences in Physics and Mathematics, Professor of the Department of High Energy and Elementary Particle Physics of St. Petersburg State University, is the thesis supervisor. 4 published works describe the research findings. They include no papers published in peer-reviewed journals recommended by the Ministry of Education and Science of the Russian Federation. And there are 3 papers in publications indexed in Web of Science and Scopus. The candidate has submitted the full set of documents to the academic secretary, and the above-mentioned documents comply with item 12 of section 3 of the order. And all the documents submitted by the candidate, as far as I'm informed, comply with the requirements and are kept in the certification file of the candidate for the degree, and curator of the defense, the member of the Department of Dissertation Board Support, has all the copies. And before I give the floor to our candidate for the degree, I would like to ask the members of the board if there are any general questions to the candidate for the degree, and is there a need to consider the whole set of documents submitted by the candidate for the degree? No questions, okay. So the short report of our speaker, 20 minutes. Yes, sir, you have the floor. And the report will be delivered in the English language. Yes. So, you have the floor, and after that we are going to ask the questions.
Пожалуйста.
Chairman and the members of the Dissertation Council, with your permission, I will present a report for my dissertation work for the degree of Candidate of Physical and Mathematical Science on the topic Quantum Aspect of the Problem of Time in Gravity and Cosmology. The reason for studying 2+1 dimensional gravity is that it is a simplified model to describe the mathematical and the physical properties of fundamental problems in quantum gravity. The 2+1 dimensional solutions are physically quite different from those in 3+1 dimensions, but the 2+1 dimensional model helps to understand the dynamic of realistic quantum gravity. The 2+1 dimensional gravity was first recognized in the Hamiltonian formulation of point particles. The importance of 2+1 dimensional gravity appeared after the work done by Deser, Jacqui, and Toft, as well as Witten. On the other hand, the 2+1 dimensional gravity is a toy model for the 3+1 dimensional gravity, and some of its results could be generalized to 3+1 dimensions. The spacetime is locally de Sitter, for a positive cosmological constant, while it is anti-de Sitter for a negative cosmological constant. Physically, there are no local degrees of freedom for a 2 plus 1 dimensional spacetime, as gravitational waves disappear in classical theory and there are no graviton in quantum theory. We study a spherically symmetric dust shell as an example of 2 plus 1 dimensional gravity representing gravitational collapse. Spherically symmetric dust shell is a generalization of the point-like particles, and its dynamic was studied by Israel. We investigate the Hamiltonian structure of a spherically symmetric dust shell in 2 plus 1 dimensions for both zero and the negative cosmological constants. In 2 plus 1 dimensions, spacetime has a BTZ black hole solution for a negative cosmological constant. Moreover, spacetime is locally flat in a vacuum, and the spherically symmetric Einstein theory has no local degrees of freedom. This emphasizes that the reduced phase space is finite dimensional in the Hamiltonian formulation. The momentum turns out to be the group manifold SL2. We use the representation theory of SL2 to investigate the structure of the dust shell. The coordinates are commutative in a vacuum, but it is not necessarily true for a negative cosmological constant. In the case of a negative cosmological constant, we focus on studying quantum dynamics in the near horizon area, where we can neglect non-commutativity momenta. The momentum non-commutativity exists away from the horizon and requires a quantum group technique. Quantization of dust shell is fully investigated, and the spectrum of areal radius of the shell is found. For a zero cosmological constant, the spectrum indicates that the negative singularity is resolved in the time-like movement of the shell. For the space-like movement of the shell, singularity belongs to a discrete spectrum and is also regularized. For a negative cosmological constant, we obtain transition amplitudes between different locations of the shell in the near horizon area. Here we briefly describe the canonical formalism for a spherically symmetric gravitational field in 2 plus 1 dimensions. In the existence of a thin shell, the action for this system consists of two terms. The first term represents the standard Einstein-Hilbert action for the gravitational field, while the second term represents the dust thin shell action and is given by equation 2. Note that hat denotes the value of variables on the shell, and m is the shell rest mass. The single Hamiltonian constraint describing the dynamic of the shell is related to Israel equation. They give an explicit relationship between the surface energy momentum tensor and the extrinsic curvature tensor difference between the two sides of the thin shell. Equation 3 is a constraint to be used in quantum theory. We note that the above equation contains square root in it, which are not a single valued function. Also, different choices of the sign in front of square roots correspond to different sectors of the phase space of the model, which are pictured as different regions on Penrose diagram. The same m correspond to different points in momentum space. Moreover, the Killing time and the radial momentum diverge at the gravitational collapse point, where 2m is equal to 1. One way to overcome this problem is to introduce a complex phase space and to assemble different batches into a Riemannian surface. However, there is still a possibility that there exists another set of real phase space variables that would cover it globally. The Sharon-Simon action depends only on one form connection and is used to describe the action for the 2 plus 1 dimensional gravity. Note that the first order formalism is equivalent to the second order formalism when trade is invertible. The action for this system consists of the standard Einstein-Hilbert action for the gravitational field and the dust thin shell. The shell consists of n particles, and we note that Li is the ith particle world line, and the Ki is a fixed element of SL2 algebra. Gravity action is invariant with respect to gauge transformation, while the shell action is not invariant. To obtain a reduced action for this model, we have to solve the constraint and plug the solution back into the initial action. We choose a slicing so that the particle world lines move along the time coordinate. We divided the special slice into regions. Each region should contain no more than one particle. We draw a circle around each particle such that the circle are connected to a common origin but have no common boundaries. By making cuts along the circle, the manifold is divided into n disks, each containing a particle, and a polygon containing no particle but connected to infinity. Hence, the simplistic form for the disk collapsed to its boundary is given by equation 5. Similarly, for polygon, whose boundary consists of n edges, the resulting simplistic form is a sum of contribution from every edge and is given by equation 6. The next step is to assemble pieces of the simplistic form and apply the condition of continuity of metric and the connection across the boundary between the disk and the polygon. After Hamiltonian reduction, the simplistic form in a simple form is written in terms of the holonomy around the full shell and the shell space-time coordinate parameterized by SL2 algebra. The holonomy around the full shell can be derived by making use of cylindrical symmetry. The first term represents the transitional part from the particle to the center, while the third term is a transitional part from the center to the particle. The middle term is the rotational part. Note that m is the overall bare mass of the shell and I is angular variable. One of the consequences is the Israel equation, which is given by equation 9, and where m is the ideal mass. The holonomy provides a global chart for the entire momentum space. It has an anti-de Sitter geometry. This momentum space is shown in the first figure, containing 4 different regions. This region can also be found in the Penrose diagram, where they are labeled with the same way. We briefly describe the quantization of the model using momentum representation. There is one less degree of freedom due to spherical symmetric. We define the kinematical state of the model as a function of holonomy as a single valued function on the entire momentum space. We note that the time operator has a discrete spectrum and its eigenstate are given by equation 12. There are 2 ways to calculate the radius of the shell. One way is by evaluating the distance from the center to the shell, and the other is along the perimeter. Notice that the Peterhof radius depends not only on canonical coordinate, but also on the total mass, which is a function of canonical momentum. The Peterhof radius is defining the size of the shell, and its square is the Peterhof Laplace operator on our momentum space. The shell radius has a continuous spectrum for the positive values of x square without 0, while it has a discrete spectrum for negative values of x square containing 0. The quantum version of the Hamiltonian constraint is the Klein-Gordon equation for relativistic particle. Due to periodicity in the energy variable, this is not a differential equation, but a finite difference equation, which is in agreement with the discreteness of time. A matrix element of an operator U represents the transition amplitude from the eigenvalues of discrete spectrum to the eigenvalues of the continuous spectrum. It is calculated numerically and equals to a non-zero and finite value in which the shell radius collapses and returns back again. The gravitational collapse rate is described by a matrix element of the evolution operator between eigenstate of the shell radius r for positive r square and for 0 r square. In this figure, we show the result of numerical calculation of the absolute value of matrix element for different values of R square for a zero cosmological constant. One can see that this value is everywhere finite, including minimal possible positive eigenvalues of the shell radius when R square is equal to 1 over 4, which can be interpreted as the resolution of the central singularity. Here we calculate numerically matrix element between various states, which describes the rate of change of the shell radius for a negative cosmological constant. For example, in this figure, we show the relative rate for the shell to across the horizon from region 1 to region 2 and back. As one can see that the transition rate from inside the horizon to outside the horizon is comparable to that from outside the horizon to inside the horizon, in close vicinity of horizon, but become exponentially damped away from the horizon. Quantum theory of a model describing a dust shell coupled to 2 plus 1 dimensional gravity with 0 and a negative cosmological constant has been studied both at the kinematical and dynamical levels in a near horizon region. At the kinematical level, it was shown that the time operator has a discrete spectrum. Also, the shell radius has a continuous spectrum outside the horizon and a discrete inside. The eigenvalues spacing of the shell radius measured along the radial coordinate is Blanken, while for the radius measured along the perimeter of the shell, the eigenvalue spacing is proportional to the square root of the black hole mass. Although the used approximation don't allow us to go deep inside the black hole, one can tell that the point of the central singularity, the zero radius of the shell, belongs to discrete spectrum. This is suggestive of singularity resolution. At the dynamical level, we obtain transition amplitude between different locations of the shell in the near horizon region. It was shown that there is a non-zero transition rate between all possible sectors of the Penrose diagram, even between those which are classically forbidden. However, for the classically forbidden transitions, the rate is exponentially damped away from the horizon. Away from the BTZ black hole horizon, the momentum space becomes a quantum group. This part of the work is not completed, and some basic results have been found. At the kinematical level, the spectrum of the shell radius is also discrete and bounded between the black hole horizon and the white hole horizon. To study the model at the dynamical level, one needs to solve the factor ordering ambiguity problem in the matrix element. The main reason for studying the cylindrical symmetric shell model is that it could be extended to 3 plus 1 space-time dimension. The only difference is the presence of Newtonian potential. Thus, in principle, there is a possibility to generalize this result to 3 plus 1 dimensional gravity. This work is based on the following published article, and thank you for your attention. Now you are welcome to ask any question.
Спасибо.
Thank you. Now, let's ask the questions on the reports that provide a major overview of the thesis. And 10 minutes per question, I would like to repeat. Does anyone have any questions? Victor, your microphone is turned off. You want to ask something, do you? So yes, we do hear you now. No, I have no questions. That's okay. Okay, let's shift to our next part. The speeches of the members of the board with their reviews and assessment of the thesis and the authors to of opinions to our candidate for the degree, and the candidate for the degree can answer all the questions at once, or may answer the questions after each review, and I offer to answer the questions after each review that you are given. Okay. So we have no external reviews. Am I right? Yes, okay. Now let's switch to the reports of our members of the board. So the reviews were submitted before the introduction of the new classification code. Dear members of the board, I would like to ask you if you agree to recognize your reviews as the ones that comply with the new scientific specialization code 133, theoretical physics. Yes, certainly. Yes, we agree with that. Okay, thank you. So everyone agrees about that. So as all the reviews were already published on the website of St. Petersburg State University, I would like to ask you to give just the major points, the questions and remarks to the candidate for the degree. So don't read out all the review. Do you have any objections about it? No. None at all. Okay. Okay, then let's shift to our reviews. And first of all, let's give the floor to Professor Jung. Professor, are you ready? Yes, I am. So please, you have the floor. Yes, I won't read out my review. I'll just shortly say that the problem of singularity is one of the most important problems in the gravitation theory. And in quantum theory, these singularities will be leveled out. However, the gravitation theory and the most promising approach here is the theory of string. However, the full gravitation theory cannot be established fully today. Therefore, it's important to find certain simplified versions of gravitation that allow us to analyze the situation. And one of the simplified versions that is being considered in the thesis is 2+1 dimensional gravitation, that is a topological theory of Chern-Simons, and does not contain local freedom degrees, and therefore it's a simpler theory, gravitation theory, than 3+1 gravitation. And unlike a quantum field theory that has a full set of degrees of freedom, 2+1 dimensional gravitation is described by a finite number of degrees of freedom, and it means that we are not working with field theory, but with quantum mechanics. And this approach is developed in the thesis, and he studies the collapse with a spherical dust shell that interacts with the field in 2+1 dimensional space. And I won't give a review of what I've already written, and I'll shift to the comments that I had. So it seems strange that the time coordinate can take just discrete values. Technically, it emerges due to this requirement of periodicity of the wave function on momentum. And the quantum of time is defined by the constant of Planck, and it does not dependent on the space until the dust shell. And if we consider the remote spaces, the time will still be discrete. Physically, it's not quite probable, and periodicity of the wave function on momentum emerges when we describe the field shell and the dust shell, and it is not universal characteristic of 2+1 dimensional gravitation. It seems strange that the quantum of time is not trying to achieve zero when it becomes remote. And above all, there is this doubt on the opportunity to generalize the results into 3+1 dimensional theory. 3+1 dimensional gravitation is not a topological theory, and it has infinite number of the degrees of freedom. Its quantum characteristic is not reduced to the quantizing of several degrees of freedom, and there will be the problem of non-renormalizability of this theory, and the thesis actively uses spherical symmetric solutions, but even if classical equations have spherical symmetry, then quantum fluctuations are not necessarily spherically symmetric, but these results don't compromise the value of the obtained results, and overall the thesis is a finished academic study in the quantum theory, field theory, and gravitation. The study is performed at the high level. The results are novel and original, and they were timely published on in scientific journals. And the thesis by Yasser and Elmahalawy, titled "Quantum Aspects of Problem of Time in Gravity and Cosmology," meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University. And Yasser Elmahalawy deserves the academic degree of the Canonical of Sciences in Physics and Mathematics in specialization 133 Theoretical Physics. And Article 11 of the above-mentioned order is not violated. That's it. Okay. Thank you so much. Yes, sir. Your answers. Yes, you have the floor, please.
Firstly, many thanks for your comments. Regarding the first comment, since our formalism is based on homogeneous canonical theory, the time coordinate is considered as a dynamical variable. In our opinion, the standard formulation where the time coordinate appears as a parameter is based on the choice of the special gauge fixing condition. If we take another gauge fixing condition, we may have an alternative form of quantum mechanics. Also, the concept of discrete time was set recently by Frank in solid state physics and is specified as a time crystal. Evidently, when the period of energy increases, the time lattice approaches the continuum, and one comes to classical dynamics with a continuous time. Also, in 2+1 gravity, interaction energy between particles does not depend on distance. This is one of the sequence of 2+1 gravity being a topological field theory. This is the reason why the spectrum of the time operator in 2+1 dimensions is equidistant. In 3+1 dimensions, where gravitational interaction decreases with distance according to Newtonian's law, the discreteness of time operator would indeed disappear far away from the shell. Regarding the second comment, I agree with you that the theory of 3+1 dimensional gravity has an infinite number of degrees of freedom. These numbers can be reduced due to the spherical symmetry of the thin shell. The problem of non-renormalizability and the quantum fluctuation can be disappeared based on the choice of the special gauge fixing condition. Also, we consider a symmetry reduced model, not a spherically symmetric solution in the framework of the full theory. Thus, we end up with a model having only a finite degrees of freedom, which simply does not contain a fluctuation around the spherical symmetric solution. And thank you.
Спасибо.
Thank you so much. Alexei, any comments to the answer? No? None? None of them? No comments? I'm satisfied with the answer. Okay, thank you so much. Now I would like to give the floor to Victor Berezin. So please, Professor Berezin, you have the floor. Thank you. Do you hear me? Yes, I do. So I would like to start with the fact that the topic of the thesis can be defined as quantum gravitation. So I'll start with that because you can see it from the title. And the sources of attempts to create quantum theory of gravitation rise to the work of Matvei Bronstein in 1936. That's a well-known St. Petersburger that unfortunately perished in 1937 or 1938. But since then, a lot of attempts were undertaken and a lot of advances were made. A lot of equations were developed, and Bryce David paid a lot of attention to create hydrodynamics of the classical theory. Then quantum theory was developed by David and colleagues. But regardless of that, of these numerous attempts and huge efforts of outstanding scientists, we still have what we have. And as it was already mentioned, the gravitation quantum theory that is based on the one that is considered in the thesis is not renormalized in 2 plus 1 dimensionalities, 3 plus 1 dimensionalities, but if we add up some terms, then it becomes renormalized. And as for the form, so we can sort it out. But the question is that this theory is non-linear, and it's associated with the fact that gravitation field has its theory as well, has its energy as well. But I paid attention in my review to the substantiation of the choice of T plus 1 dimensionality. What's the main problem here? The main problem is not in renormalizability, but it does not allow us to create the quantum gravitation theory. That's what graviton does itself. So that's an acting field, an independently acting field, and that's the major obstacle to the development of the theory using the type of quantum chromodynamics, where you have this fluctuations theory or disturbance theory. Here, this disturbance theory can work only on weak fields. The main thing is non-linear characteristic, and that's the main obstacle here. And why do we like 2 plus 1 dimensionality? As you see, that's the Chern-Simons theory, a logical theory, and it has no local degrees of freedom. And unlike 3 plus 1 dimensionality, where the spherical symmetric space-time has no gravitation waves or gravitation degrees of freedom, but still the limitation, these limitations can quickly change the physically valid results, and there is no such threat here, and that's important because the theory is fully independent from additional symmetries like two-dimensional or spherical symmetry as it's considered in the thesis. Gravitational degrees of freedom was something that we didn't have. And above all, there is a question, how should we quantize theory if it's such a topological theory as the theory of gravitation? The thing is that quantizing empty space without a source is something that is quite useless. And therefore, we need to quantize the theories with a source. And the source should be as simple as it can be, so that the theory would be described by the finite degree of freedom, and this quantum field theory would turn into quantum mechanics. And the thesis, I believe, has done it quite successfully. The author has chosen infinitely thin shell, the classical theory for such shells for four-dimensional space, but it's still generalized for the space of any dimensionality. And Werner has provided such an theory, and this theory allows, in classics, to obtain exact solutions, and exact solutions are the basis of our physical intuition. We are being based on the results of exact solutions, and we can see what's correct. And, for example, if we use numerical calculations, what can give us a failure. Therefore, exact solutions are particularly important, especially in quantum mechanics, and we know it quite well based on our own experience with quantum mechanics, because everything is much more complicated there. Therefore, exact solutions are particularly important. So how can we obtain an exact solution? Certainly there's no general solution, therefore we introduce additional symmetries. But unlike 3+1 dimensionality, 3+1 spacetime, when we have limitation for spherical symmetry that does not allow to use local degrees of freedom as gravitational waves, here this limitation does not ban anything. It does not ban these local degrees of freedom. We don't have them, as we didn't have them. And thus we have more trust to these exact solutions, regardless of the fact that, as it was mentioned before by the previous speaker, still there is this expansion of results and calculations from calculations of 2+1 dimensionality to 3+1 dimensionality. But as it was already mentioned in the thesis, this coincidence of quality responses means quite a lot, and this quality response is that we managed to avoid singularity. So the wave function in singularity equals 0, or as it was shown here under the horizon of events, where the radius becomes a time-like coordinate, not just space-like coordinate. But then the general quantizing of time that emerged in this problem gives us the result. So it leads us to quantizing of the radius, and this means that we don't have this zero quantum radius. Now I would like to say a few words about the quantizing of time. It seems to me, and it's hard to prove it, maybe the author will do it, maybe the author will manage to answer this question. Why, all of a sudden, we quantize time everywhere, including the remote distances from the shell? I have such an impression that it is associated with the fact that both 2+1 gravitation is a topological theory, and in topological theory, even the emergence of one single point can change all the situation completely. And this particular point is this thin shell, because as it was mentioned before, we have the topological Chern-Simons theory here everywhere except for the shell. And the shell that brings two space-times together, this shell is quantized, and it is quantized globally rather than locally. And thus we get a global quant gravitation. We quantize global characteristics of space-time in T+1 dimensionality. And these global characteristics can be influenced by topological structure, because inside of the shell we have one topological structure. In the externality it is different, and we can have different solutions inside and outside, and the shell just brings them together. And the fact that this shell itself is not symmetrical as the space-time outside it has an influence, and it leads to quantizing, and the quantizing of the shell leads to the global quantizing of the surrounding space-time, and this, I believe, will give us the most promising result in this thesis. Unfortunately, the current authors, here I'm referring to to the author, to supervisor and co-supervisor. Unfortunately, the authors did not manage to resolve this problem completely because, unfortunately, we don't. The impulse and momentums are not commutative, and this requires the consideration of quantum groups, and it's really incredibly hard. But still, even the obtained results show that basically the author is fully ready for independent work, and the level of the degree of the candidate of science gives us an opportunity to work independently. And I believe that this thesis complies with all the basic requirements of the thesis, with the requirements that is set by the order on the procedure of granting academic degrees at St. Petersburg State University. And Yasser Elmahalawy deserves the academic degree of the candidate of sciences in physics and mathematics in specialization 133, theoretical physics. So that's my opinion about this thesis. And what I can say once again is that the author has chosen very complicated mathematical methods, and the author and his co-authors have managed to successfully cope with all the methods. Thank you. Thank you so much. Yes, sir, do you have an answer to that?
First, I would like to thank you for your remarkable comments. And second, I agree with you that 2 + 1 dimensional gravity has a similar structure as 3 + 1 dimensional gravity, but with lower dimension, in which degrees of freedom can be reduced. Also, we choose a symmetry reduced model, not a spherically symmetric solution, in which degrees of freedom can be reduced also. And in this case, we turn to quantum mechanics instead of quantum field theory. Regarding the problem of time, in 2 + 1 dimension gravity, interaction between particle does not depend on distance. And this is the reason why the spectrum of time cooperator in 2 + 1 dimensions is equidistant. Also, recently, Frank in solid state was said that the discrete time of crystal in solid state, and he found that the period of energy increase the time lattice approaches to the continuum and comes to the classical dynamic with the continuous time. And thank you for your comments.
Спасибо. Виктор Александрович, вы удовлетворены?
Victor, thank you very much. Are you satisfied with the answer? Yes, I am. Okay. Now let's switch to our next review. And I would like to give the floor to Professor Kamenchik. So please, Professor, you have the floor. Thank you. So this work covers quantizing of gravitation, the problem of time, the problem of singularity, and despite the fact that this problem that this model is relatively simple, as it was mentioned. Still, in this model it's quite hard to work, and the author managed to obtain very good results. I would like to dwell upon the following problem. We know that gravitation theory of any dimensionality of time and space has parameterization in variability, and in quantum theory this gravitation, according to the major equation, it has no time, it has no problem of time. And this equation is time independent, but still we know that in real life time exists, so it is somehow hidden in the Witte equation, and this problem has long been discussed, and the Witte articles were published on that, and there are different approaches, but they are all reduced to the fact that time is somehow introduced, being a combination of other basic variables. And here we can have two choices. We can consider time as a classical time, and that quantum nature of those phase variables is frozen, and they are considered as classical, and other degrees of freedom are considered as quantum ones. But we can still consider time as quantum object that is associated with introduction of operators that form the time that we have. And in this work, as far as I'm concerned, this time is an operator and the spectrum is discrete, and that's quite an interesting result. And that it turns out discrete on any distance that is associated with the topological nature of the model. And the question is, as time has discrete spectrum, can we consider quantum states that are superposition of the states that correspond to different moments of this discrete time, or not? Or maybe we have certain rules of selection that would allow us to consider just the states associated with one moment of time when this time becomes discrete. But I won't dwell upon other aspects of work, because previous colleagues mentioned them as well. I can just say that certainly the work is quite satisfactory. It meets all the requirements to the thesis, to the works submitted for the award of the academic degree of the Candidate of Sciences, and I believe that the author deserves this degree as well. Thank you. Thank you so much. Yes, sir. So, your answer.
Regarding the problem, the discreteness of the time, it is still an open question. And as I said before, in 2+1 dimensional gravity, interaction between particles does not depend on the distance. And this is the reason why the spectrum of the time operator in 2+1 dimension is equidistant. And in 3+1 dimension, the situation is changed, and the discreteness disappear far away from the shell. Again, thank you for your report.
Спасибо. Александр Юрьевич, вы...
Thank you so much, Alexander. Are you satisfied with the answer? Yes, yes, I am. Yes, I am. Okay, thank you. Now, I would like to give the floor to our next speaker, Alexei Golovnev. So, please, Professor, you have the floor. Yes, thank you. Indeed, I would like to say at once that I believe that this thesis is dedicated to very important aspects of theoretical physics, and it complies with the specialization regardless of what code the minister would give to it. And the results are quite fascinating, and here I won't go into details and describe all the contents of the thesis. I would like to say that I liked the results, but still I would like to see more the opinion of an opinion of the author about some things that we would see the place of the obtained results in the general picture that we have. I would like to see the prospects of this work, and overall I've already given that in my review, some technical inaccuracies in formula in words. There's nothing quite serious about it, but I would like to dwell upon the title of the thesis. the problem of time. I like this title, and I believe that this issue is of fundamental of some fundamental issues, what time or what role the time plays. So these are more important aspects for quantum gravitation. I believe I won't worry about renormalization or non-renormalization. But as for the type of time problem, certainly that's an important issue that really is quite fascinating. But on the other hand, if you chosen such a title for the thesis, it would be nice to see the discussion of the problem of time in the text. You know, such a pronounced discussion. Unfortunately, the text lacks it. However, the problem of time is dealing with the main essence of the thesis. But these are just, you know, rather style comments about the style of the text. But overall, I believe that the thesis is quite a good one. The results are really interesting, and I hope that the author will continue working in this field and will obtain even more fascinating results. And overall, all the requirements are met as far as I'm concerned, and I'm sure that Yasser Elmahalawy deserves the academic degree of the Canonical of Sciences in Physics and Mathematics. So that's it. Yes, thank you, Yasser. You can answer the comments.
And careful reading. In the introduction chapter, I have mentioned different methods of quantization of gravity as they represent the development of quantum gravity. Indeed, these approaches are far away from the scope of the dissertation. I agree with you that the Poisson bracket in question 1.34 of the dissertation is due to the symmetry of the matrix element tensor, and not due to the form of the action. Also, I agree that the Hamiltonian is 0 in equation 1.104 of the dissertation. Overall, I had to improve the structure of the text accurately to be readable. The most important question regarding the choice of the title of the dissertation. The problem of time has been briefly discussed. We have pointed out that the time operator has a discrete spectrum because of the periodicity of the wave function in energy. In addition, the problem of time manifested for the case of multi-shells and for a positive cosmological constant. And thank you for your comments.
Спасибо. Алексей Валерьевич.
Thank you so much. Alexei, are you satisfied with the answer? Yes. Yes, I am. Okay, thank you. So, Professor Paston, you have the floor. Thank you. This thesis is dedicated to the study of certain approaches to the quantizing of gravitation, and I believe that that's quite a relevant and important topic, because we know it quite well that the classical gravitation theory is quite a good one. We have this relativity theory of Einstein, but as for the attempts of developing quantum gravitation theory, they are quite problematic. Different researchers define different problems. Some believe non-renormalization is more important, and to others the problem of time is more important. But in any case, right now, we don't have a universally recognized quantum gravitation theory. And it seems to me that without such a theory, our worldview is insufficient, is not full. Therefore, every advancement on this path is quite useful for contemporary theoretical physics. And maybe regardless of the fact that many people note that quantum gravitation effects would unlikely be seen experimentally quite soon, but still it seems to me that without this theory, without this break in the wall, we don't have a good understanding of the world. The thesis considered canonical formalism for 2 + 1 dimensional gravitation in the presence of symmetrically located matter, and the thesis also studies the geometry of phase space And there is the quantizing of the model that's being performed, and the results that were obtained, they are quite interesting to my mind, and the model is quite complicated regardless of the fact that it's 2 plus 1 dimensionality, and it's really interesting to see this hope to summarize the results for 3 plus 1 dimensionality. In many parts of the thesis we see the description of these hopes, but as the speakers noted before, you can doubt it more or less, but still let's believe that there is such a hope and maybe some generalization is possible, and this would be great, certainly. I won't go into details about the structure of the thesis, but I'll say that it has 5 chapters. The first 2 are an overview, and all the results are concentrated in chapters 3 to 5. The results are well published and delivered at the conferences, therefore everything is okay here about that. I don't have certain serious remarks. I would like just to mention such, documentation issues. I've read the Russian version of the text, and unfortunately I've seen that there are many misprints there. There are some English phrases, and certainly it can be seen that the text was written in English and then it was translated into Russian, but still the text is quite readable, and taking into account the fact that English is not a native language for our author, the text is pretty good. And in the text sometimes I've seen such problems with logic, and I've matched it with the English version, and this was not the result of the translation. Therefore I would like to draw attention to one point. For example, you write this phrase: during the recent years, T plus 1 dimensional gravity was first theoretized by Spherically in order to study the classical behavior of a point particle. And there's a link to the work of Spherically of 1963. And quite recently, I believe that's not, and that's not, quite a recent work. Certainly, these are some negligible comments. I liked the thesis, and summarizing, I would like to say that the thesis certainly meets all the requirements to such works, and I believe that Mr. Elmahalawy deserves the academic degree of the Canonical of Sciences in Physics and Mathematics in Theoretical Physics. Thank you. Thank you. Yes, sir, you have the floor to answer.
Many thanks for your comments. Firstly, I apologize for the grammatical mistake in the Russian version of the dissertation, as I am not a native speaker and due to the lack of knowledge of Russian grammars. Secondly, I also apologize for the typos in the context of the dissertation. And regarding the generalization of our result to 3 plus 1 dimensional gravity, we will take this in consideration in our future work. And thank you for your comments.
Спасибо, Сергей Александрович.
Thank you, Sergey. Are you satisfied? Yes? Yes, I am. Okay. So finally, the last review to be read, that's mine. And indeed, what I've already written, the colleagues have already mentioned, and I have nothing new to add up here. But generally, summarizing, I would like to say that the work is performed at a high theoretical level. Indeed, we do have certain misprints, but basically they are not significant, and they never prevented me from reading comfortably. The problem of quantizing of gravitation is a very old one and a complicated one, and you need to be very bold to work with the issue, not to be afraid of this complexity to obtain new results, but still partially the author managed to do that in his thesis, and this is something that we should praise. And the results are novel. They are original, and they were published in the leading theoretical physics journals. And as for the scientific part, My major comment was already voiced several times, and in the end of the text he made an assertion that these calculations can be generalized for 3+1 dimensional gravity, but no serious substantiation about why we can do that is something that well, we haven't seen it for such a summarization. And this summarization certainly is quite a bold one, because physics in 2+1 dimensionality and in 3+1 dimensionality has certain classical differences, and summarization of 2+1 theory to 3+1 theory is quite untrivial, and it's not always possible, even for any for every field theory. And it seems to me that that's a bit dubious, how these computations without certain degrees of freedom, therefore having no Newton limit, and for example Chern-Simons theory, how can they be directly transferred to the theory with local degrees of freedom with a defined classical Newton limit? But still, this remark was already mentioned several times, and I would like to remind that this remark does not compromise the overall high value of the results that the author managed to obtain. Therefore, I believe that the thesis of Yasser and Elmahalawy, entitled Quantum Aspects of the Problem of Time in Gravity and Cosmology, meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University. And I believe that Yasser Elmahalawy deserves the academic degree of the candidate of sciences in physics and mathematics. And specialization 133, theoretical physics, in Article 11 of the above mentioned order is not violated. Thank you. Yes, sir, do you have an answer?
Thank you for your valuable remarks. Firstly, I apologize for typos in the context of the dissertation again. Secondly, I coincide with you that 2+1 dimensional gravity has a similar structure as 3+1 dimensional gravity, but with lower dimension in which degrees of freedom can be reduced. In two spatial and one-time dimension, general relativity turns out to have no Newtonian limit. Also, I have mentioned that there is a possibility to generalize our model to the case of 3+1 dimension without clarifications. This is due to the choice of the real global parameterization of the momentum space. The momentum space structure is investigating using the representation theory of SL2 group and has an anti-de Sitter geometry. Also, the Euler angle support a global parameterization of that manifold. It has also such features such as coordinate non-commutativity and discreteness. The only difference is the presence of Newtonian potential. Thus, in principle, there is a possibility to generalize this result to 3+1 dimensional gravity. Also, there is one less degree of freedom due to spherical symmetry. Furthermore, this result can be extended to the full theory of gravity in 3+1 dimension, but to some symmetry-reduced models. With the condition of spherical symmetric, gravity has no local degree of freedom, even in 3+1 dimension. And we have quantum mechanics instead of quantum field theory. Finally, no statement about the full theory of gravity in 3+1 dimensions were made. And again, thank you for your comments.
Спасибо, я удовлетворен полностью вашим.
Thank you so much. I'm satisfied with your answer. And now let's shift to the next point in our point in our agenda, the speech of the academic supervisor. So please tell us about the candidate for the degree and about his work. Yes, do you hear me? Yes, yes, we do. Okay. Well, in my review, certainly I've already written about the content of the thesis, about the plans that we had. and the plans were quite huge, and we managed to do a lot still. And certainly we will continue our cooperation with the author, and I would like to concentrate not just on the content that was mentioned and on the speech of the candidate for the degree, but I would like also to mention how we work together. Indeed, this is not a unique situation. This happens. Such things happen. Though formally, that's quite hard to do it in documents. So this supervision was a kind of double. One is sitting here, and there was also Artem Stradovtsev. And therefore, this responsibility was taken by me, and this responsibility for the university and the responsibility for the quality of the study is something that we shared with Artem, and it's hard to say who had more responsibility. And this was luck, sheer luck, because the topic is quite complicated. Certainly, I was interested in it, but before our work with Yasser, and by the way, we had works with Alexander Kamenchik that worked with quantum cosmology. However, in the gravitation quantizing, I had no works in the field, and we started writing them during the process of work on the thesis. And here, Artem really worked a lot. He led our team. So in my practice, I managed to document this co-authorship in the 80s, you know, in the start of 90s. Since then, I didn't have such a chance. And this was, by the way, the joint work with Mikhail Yoffa. This was a joint work with our Georgian candidate for the degree, so we managed to do this co-authorship then. And the next attempt failed, and we never gave it another try. But finally, yes, I'm explaining the real situation. And now a few words about what was written. These articles were written in co-authorship with Artem Stradovtsev and me. And in all these works, the role of Yasser Elmahalawy was the key one. And co-author, I believe, agrees with that. Yes, we need to fix it. That he had this original element in his study. And in his work, he combined physical intuition with an ability to use complicated mathematical methods to study, to fulfill the set goals. And generally, the thesis is a fundamental theoretical study in the field theory, and it is performed at the higher theoretical level, and the results are quite novel and original, and they were timely published in the leading journals. And basically, the assessment on to what extent the author deserves the degree is something that should be given by the board members, but I would like to say that it meets all the requirements to such works, because we did our best, and the author Yasser Elmahalawy certainly deserves the award of the academic degree of the Candidate of Sciences in Physics and Mathematics. in specialization theoretical physics. So that's basically it, what I wanted to say. Okay, thank you. Distinguished colleagues, does anyone want to say anything? Or maybe the colleagues who are not the board members but are still sitting here, maybe someone wants to say something? No, no one. Okay, now let's move further. Are there any questions submitted online? No, okay. And here we stop the discussion and the taking of questions. And before we summarize and shift to the vote, I would like to ask the members of the board and the candidates for the degree if there are any questions or remarks about the procedure of holding our session, maybe the questions that are associated with online access. Alexei, do you have any questions? No. Victor, what about you? No. Alexander? No questions. Alexei? No questions. Okay, thank you. Sergey? No questions. Yasser, any questions? No? Okay. I have none as well. Now let's shift to the vote. It's 20 minutes past 1 p.m. and I have a question to the board. Dear colleagues, now before the start of the vote, we can have a 5-minute closed discussion to discuss the results of the defense. How do you think? Do we need such a 5-minute break to discuss the final results of the defense? I believe the reviews gave us the general picture and there's no need for that. No need. Yes, no need for that. Yes, I believe everything is quite clear about the author. Yes, to my mind, we were quite, our voices sounded quite in the unison. So let's continue and let's vote. And at that, I'll need to solicit your opinion publicly, every one of you. So, dear colleagues, let's make sure that the sound works. And now there are final minutes of our session. So, do we all hear and see each other? Yes, yes. Okay. So I raised the question on the award of the academic degree to Elmahalawy, Yasser, Reda, Ahmed, Abdelhamid, at the academic degree of the Canonical of Sciences in Physics and Mathematics in specialization 133 theoretical physics. And now we're going to have an open vote. Let me remind you that the decision of the Dissertation Board on conferring the academic degree is positive, provided more than 50% of the board members, but not fewer than 3 people, voted in favor. And that's in conformity with Section 23 of the Order on the Procedure of Granting Academic Degrees at St. Petersburg State University. So, Professor Jung. Yes, I believe Mr. Elmahalawy deserves the awarding of the academic degree, deserves the academic degree of the Canonical of Sciences in Physics and Mathematics. Okay, Professor Berezin, what's your opinion? Yes, I support that. I even raised my hand. As a pioneer, I also believe that we should award the academic degree of the Canonical of Sciences to Yasser. Thank you. Professor Kamenchik. Yes, I also vote for the award of the academic degree to Yasser. Thank you. Professor Golovnov. Yes, I also believe that Yasser Elmahalawy deserves the academic degree of the Candidate of Sciences. Okay, thank you. Professor Paston. Yes, I also vote for the award of the academic degree of the candidate of Sciences in Physics and Mathematics, to Yasser. I, chairman of the board, Sergei Afonin, also vote for the award of the academic degree of candidate of Sciences to Yasser Elmahalawy. Thus, distinguished colleagues, distinguished guests, I would like to say that out of the 6 members of the board who voted, all the 6 voted in favor of the award of the academic degree, and no one voted against it, and no one abstained from the vote. Therefore, we make a decision to award the academic degree of candidate of Sciences in Physics and Mathematics in academic specialization 133 Theoretical Physics to Yasser Elmahalawy. Distinguished colleagues, due to the fact that our session is held partially online, in the remote mode, I would like to ask if the members of the board or the candidate for the degree or anyone present here does anyone have any comments or objections associated with our remote access to the defense? So, dear colleagues, Alexei, Victor? No? Alexander? No? Alexei? Any comments? Sergei? No comments? And I also have... Yes, I also have no comments about that. So, yes, are any comments on that? No? None? Okay. Now, I would like to give the floor to our candidate for the degree for the conclusion. Yes, sir, please, you have the floor.
Alexander Andrianov for his valuable ideas and comments during my PhD program. His encouragement and support have a powerful effect on my current work. I am looking forward to continue our cooperation. I would like to express my deep thanks to Dr. Artyom Starodobtsev for his kind assistance and discussion. His significant contribution has a positive impact on completing my PhD program. His valuable comments and helpful suggestions are very important to finish my PhD thesis on time. I really appreciate his effort to guide me through my recent publications. Also, I would like to express my gratitude to the chairman and the member of the Dissertation Council. I sincerely appreciate your consent to participate in the work of this council, for the exclusive valuable remarks, comments, and also for the discussion. I will definitely take into account recommendations and advice in my future work. I am thankful to St. Petersburg State University for its kind hospitality during a stay at the Department of High Energy and Elementary Particle Physics, where this work originated. I would like to thank all staff members at the Department of High Energy and Elementary Particle Physics for their kind assistance. Many thanks to all staff members in the Department of the Dissertation Council for the excellent work for the entire process of defense and for organizing today's meeting. Many thanks and appreciation to my family for supporting me to complete my PhD program. Many thanks to sound technician and translator. Also, many thanks to all my friends. Thank you.
Спасибо. Теперь можем поздравить.
Thank you so much, and now we can congratulate Mr. Elmahalawy. Well then, dear colleagues, I therefore close our meeting. Thank you everyone for taking part in it. Please turn off the broadcast.